In the last video, we made the settings page text entry control. So I'll take a quick look at that. And that's these controls here, where you hover over, you can click a button, type some text, you can escape to cancel, or you can enter to save, which, funnily enough, is not saved that time. So let's quickly fix that bug. I'm guessing if we click the button, it will. Yes, that'll be a focus issue with the edit text box. So in the text box here, by default binding to text, it updates the view model because it's a two-way binding. So when we edit the text in the text box, it's meant to update the view model. And likewise, when we update the view model, it's meant to update the text box, which it does. But by default, text boxes don't update until they've lost focus. And that's why when we click the button outside of the text box, it lost focus, updated, and then ran. When we pressed enter, the text box was still focused at that point in time. So quick fix for that. It's called update source trigger on the binding, and just set it to property changed. And that should fix that little bug with the text box. And you should really do that on any text box binding unless you have a reason not to, where you don't want it to update, as you go. But now do that, enter, and that works. And the other thing I keep wanting to do by just nature, I guess, is I want to kind of double click to edit. I don't want to have to hover and move the mouse and find a place. I want to double click. So, and I guess you could double click to, I don't think you really want to double click to escape. That's more of a, you just really want to double click to get in, and then you click to save. So let's add the double click. That's nice and easy. So we'll put it on the main grid so you can double click anywhere. And then here we'll do grid.input bindings. Do a mouse binding, the mouse action. Let's see which one it is. Click here, press F12. It will go to this, which is a mouse action. And then in here, these are the values we can have. So we want left double click. And then the command on that will be the edit command. And that's all there is to adding a double click to edit. So now if we double click, that's better. We can go ahead and type, double click, type. It's much easier. So that's that done. Let's just add a comment here. Double click to edit. Where did we go? And then I guess the next thing is let's start putting some actual values in here. So right now we just have text entry control. I believe in the settings view model we already did in the last video. The properties. Yeah, so we can start binding them to these real things. Name, username, password, email. We should just be able to now do binding equals binding name. Sorry, not binding, data context. So we should have name. I forgot already. Good long-term memory. Name, username, password, email. And then let's run this. I think that just needs compiling to show. Or not. So let's see why this is no longer working. So this right now we have we've set the data context here still. That needs to change back to design time. Otherwise it's overriding our explicit setting. Nope, still not. Okay, so we've got text entry control, which is this. We set a data context. And they are we in the right place? We're inside of control. The settings control has the data context set to settings, which will be, I think we bound it to a constant we have. So it'll run the default constructor, and that's why we haven't actually set them up. So in the, I think we did it in the settings design model, was it? So view model, applications, settings. Okay, we never actually made them. So I thought we'd done a settings design time model. We haven't even done that yet. So let's quickly make a settings design time model. Just go ahead and add a new folder. Then just pick any existing design class, copy, paste. And then this will be settings. Just update all the references. And then in the constructor of the design model, so this will already run the constructor of the main one, and at design time we'll have name equals new, and I'm sure we've done this. I'm sure we have. No? Okay. Deja vu. So we'll have the label for this equaling the name, and the original text equals my name. Then we'll have username equaling username, Luke, password, which is something we'll update in this video. But for now it's just text, and the email will be email, and my email. So now we have a design model. Let's rename the class. Click here, rename file. I keep saying rename class, rename file. And then as usual in the settings control, we'll now do at least a design time data context. And is this the first time I'll have managed to type the design time binding right? Nope. Why do I never remember this? Static core instance. Oh, so close this time. Instance, there we go. And you can see we've lost all style. There we go. So now we've got the data, which is looking right. It's not quite looking right in design time because it's not hiding the edit text box, but let's see if it looks right at runtime. Let's just force this to bind to, well, in fact, for now, until we do the settings view model, until we pull this information from a real backend storage, let's just put the same information in the main constructor that we can then just remove at a later date. So to do, remove this with real information pulled from our. But for now, we'll dump that in. So at runtime, we should see the same thing. We've made the exact same values. And you can see that looks correct here. So we've just got a slight design time glitch, if you will, where it's showing the edit text field, just the underline as well, strangely, not the value. Oh, we don't have a value, that's why it's not showing the value. But it's not quite showing correctly. The same here, it's showing the actual value. So, see if we can just fix that. So edited text there. Fade in property. Well, to be honest, a quick fix would just be opacity 0 by default. And that should still work because it's going to animate in when this becomes editing, and it's going to override that anyway. So I think that'll be a perfectly adequate fix. Yeah, so that's fixed the design time. The next issue we have now, as you can see, before we line these up by having a single grid with a column here and a column here, now these are independent, we have this staggered effect. So we need to fix that. So I think what we'll do is we'll wrap all this in like I think it's already wrapped in a stack panel. But we will first make it so we can set a property on the control to the length, the width. So we can change the width per one via an attached property or a dependency property. And then the main thing that we're wrapping it in, the stack panel, will add an attached property that will then enumerate its children, find the largest width, and then set them all to that, I think. So let's see how that goes. So I guess the first thing is, in this control, the actual text entry control, we need let's first clean up this. We'll now need a dependency property. So you can type prop dp tab twice, and then you can see it's highlighted the int, which is the type we want. In this case, we want, I think, a grid column length is a grid length as a type. So we will want a grid length. And of course, that's now finished the property. Okay, let's delete that and start again. Now I've got the namespace. Prop dp, tab twice, be grid length, and then tab again. The name will be, we'll call it label width. And tab again. It's taken me to the owner class down here, which will be this. So text entry control, tab once more. And then we're to the default property, which we're going to change anyway. So that's it. Just press enter at that point. And this will now complain that it wants to convert it to the new C# 7 style because of my editor file. And this will be the label width of the control. Dependency or dependency? I think it's dependency. And now we want this to be default value. We also need it to be on property changed. So default value will have grid length dot auto. So by default, it'll just be whatever it wants to be. And then the callback will create a new one. So property changed callback. We'll call it label width changed callback. And then we'll make that down here. And then I'm not sure of what it's expecting yet, but we know it's of type property changed callback. So if we just type down here, property changed callback, press F12, it'll take us to it. So it wants these values. Then the comment will be called when the label width was changed. And then D is going to be the actual, what will it be? It'll be this control, because that's what we've bound the text entry control on. What's it still complaining at? Non-static field or property. Is it got to be static? Obviously, yeah. So that'll be public static. There we go. So this will be the instance of ourself, of this control. and then the E will be the value with E.newValue. So every time the label width changes, which is a grid length, so that means now, let's put a breakpoint here, and let's show you what you can do with as it stands right now. So now this has got a label width value. So in the settings, here we can say directly label width, as if it's a property on the control. Let's say 400. And then if we run this now, we should get, there we go, so it's hit this callback. And D, you'll see, will be this text entry control, which is the one that'll have a label. Well, it's basically the one we put the value on. And then E.newValue, I think it's E.newValue, will have, there we go, 400, and the old value is auto, and the property is label width. So from this, we can now set the actual value on this control. So in here, when we get the value, we want to change the width of this, not this text block, but the column it's inside of, which is the first column. So it's this column here. So now instead of the width being auto, or we can leave the width as auto, we want to name this, and we'll call it label column definition. And now we can edit that when the label width value gets changed. So in the code behind, we'll first say, because this can also have, say in here, what you want to be careful of as well, this is a string, so somebody could do that. And we don't want that to crash the application when it's invalid. So in here, we first want to wrap this in a try catch, because the user might type in an invalid property. If it's invalid, then we will, or not return, sorry, we need to set the D as text entry control. So this, the calling controls label column definition. So basically we get an access to this column. We want to set the width to auto, which is basically what it is already by default. So we're basically assuring that it's going to be, if somebody types something invalid, we'll set it to just auto. You could also add in here some debugger, which I probably should add. Oh, hang on, we are, yeah. Why aren't it finding debugger? Let's just, there we go. So this will break if we're debugging. So make developer aware of potential issue. So at least we indicate to the developer who's debugging the application if we start getting invalid entries, and then we set it to normal. Otherwise, we want to first we want to convert the value, which is a string, to a grid length. So try and convert the string to a valid grid length. So that would be grid length equals grid length converter new grid length converter dot convert from string. I don't think there's any try converts. No, so we can't do like a try convert. Well, that's why the catch is there. So convert from string, and then E.newValue is the string, which comes as an object. So let's just force it to a string. And if that works, then set the column definition width to the new value. So pretty simple. So again, D as text entry control, label column definition dot width equals grid length. And what that should allow us to do now, grid length. Don't tell me I've made the wrong thing. Oh, it still thinks it's just a object. We need to cast it to a grid length. There we go. So now here, when we put a value, we probably have to build first. Or rather not here, in the settings. Command settings. Or is Visual Studio going to crash now? There we go. So in here, now, we should be able to put in a value. In fact, that should have already worked. So maybe we need to build again on here. this should be updating this size. Maybe it just needs closing and opening with Visual Studio. Let's first try and just run. So invalid. What? Well, you know what we should have done? At least caught the exception, so we could see what's going on. Also, turn on catch all exceptions. Control Alt and E, and then turn on this one. And this should catch every exception and simply tell us what we've done wrong. So, unable to cast object of height grid length to string. Why am I trying to cast it to string? I'm not. Oh, convert. Yeah, convert from string. Unable to cast of object of type grid length to type string. I am confused. I'm not trying to do that. Maybe it just needs wrapping around the whole thing to convert the return. Nope. Okay, what the? Convert from string. And let's just see what the value is, because something's... I'm doing something obviously wrong here, but what am I doing? E.new value. Oh, it's already... already a grid length. How did that already convert itself? I'm sure you have to convert it. Okay, so it's already a grid length, even though... Oh, of course it is. Actually, no. Oh, we've made it a grid length. That's my mistake. The dependency property wants to be a string because we want to be able to pass in text. Like, it's actually worked. In fact, no. I think what we do is leave it as that. It's working as that. Saves us having to do this cast. So grid length is already the new value is already a grid length. It's already sort of been handled by the dependency property, so we don't have to. So it saves us having to do that conversion because WPF has already done it based on the fact that we have... It's done it from this. It's converted from string to the expected type by default. So that'll actually already be a grid length, so we simply set the value. There we go. So a little easier than, well, even easier than before. So now there we go. So now you can see that's disappeared. So let's change this back to 100, say, or 10. So now we've got control of the size of the inner grid column width from outside. So we could set these to, like, say, see whatever fits. So like 100 or probably 90 even fits. And then you could do this. You could set, and we're not going to do this, but I'm just showing you. This is the effect we're after. We want to set the label width on all of them, and we want them to be the right value, but we want them to be the value of whatever. You see that E is slightly cut off, so we want it to be the value of whichever one is already naturally the biggest. So we're halfway there with that label width dependency property that can now have, you can set it on this control and change the width. So the next thing we want to do is wrap the whole thing in a stack panel, which we have. So these are all in this group. All these are inside. And then we're going to make an attach property that we attach to this. And this will simply then, well, you'll see what it does. It's easier to do than explain. It's text attach properties, I guess it's it's more panel. Panel child margin, so let's just copy that one. We'll call this... I don't know, it's going to be specific to the text entry. Well, it's not the text entry, is it? Well, it is. It's just call it text entry. We can always rename this. Text entry width matcher. I don't know. That's what it's doing. And this will match the label width of all text entry controls inside this panel. Copy that to there. The type attach property is going to be a boolean. We just want true or false. Doesn't really matter. We're not even going to use the value as such. So in here we get the panel, which is fine. Then we want a function to we want to set the width initially. So the problem we'll have with design time showing this correctly is this loaded won't fire. So we're going to call, we'll wait for it to load, then we'll work out the widths, and then we'll monitor size changes. But in order for the design time editors to also show, we'll call it at least once here anyway. So call set widths initially. This also helps design time to show the right to work. Let's put. We haven't made this yet, but we know we'll have a function called set widths, which we'll implement in a minute. Then you'll wait for the panel to load as before. And we also want to fix this because this is we found out before that this can be called more than once. So let's turn this into a single fire. So we'll have a rooted event handler onloaded equals null. Then we want to define that. So onloaded equals, and then that. And then we'll have panel.loaded plus equals onloaded. Hook into the onloaded event, or hook into the loaded event. As soon as we have loaded, we want to unhook so we don't fire again. So if this gets called more than once, we don't fire it more than once. Then again, so unhook. Here we then want to set the widths of all the child controls. And then I guess also for every child, similar to the last loop, we want to hook into any text boxed entry that has its size changed, because then we want to recalculate the widths. So first we want to ignore anything that is not a text entry. And we'll have to update this when we add a password entry field as well, but we'll do this for what we currently have and come back and fix. So ignore any non-text entry controls. So if child is text entry control, and then if it's not, so basically if it isn't a control, then continue the for loop, ignore this one. If it is a control, if it is a text entry control, then we can do control dot label, which is the only thing that's going to affect, and we don't have access to the label, do we? So we need access to the label. So let's first jump back to the text entry control. This is the only thing inside that column that's going to affect their width. So let's give this a name, and this can be label. And then in here we now have the control.label. If I could type control.label dot size changed, and then every time the size changes, so I'm just giving them unique names. I'm not using them anyway, so I don't really care what the names are. So when the size changed, just set the width again. So now what will happen is when we attach this to this stack panel here, which will be like so. So now we have an attached property on here that's true, so it'll fire. Come into here, it'll call set widths, and this is mainly again for the designer to work. Then it'll wait for the panel to load. Once it's loaded, it will call set widths again, which will, update the widths. We'll iterate through the children. And then it will loop through all the children, and we'll start monitoring for the size changed. And when the size changes, we will set the widths again. So all in all, we're basically trying to keep a monitor on whenever the children's widths change to then call this function. So this is now going to update all child text entry controls so their widths match the largest width of the group. And then in here we want to keep track of the max size, which will be a double. Maximum width. Then we'll have for each child again in panel.children. Oh, let's better pass the panel in. So that is the panel. And there. Add a comment. For each child in panel.children. Again, we want to ignore any non-text entry items. So for each text entry, we don't want to get there. We want to set the max size equal to math.max, so the biggest one of the two, the already existing max size, and the child control, we called it. So this text entry control, the cast control, .label render size. Now the thing with the render size is that that's the value we want, except the render size doesn't include any this padding that we have, this margin rather here. So the render size is that, the margin is excluding rendering, it's simply a spacing. So we need to add the margin as well. So we need to add the left and right margin. So I'll have the control.label.margin.left plus control.label.margin.right. So that will find if this value is larger than the other controls. So this will loop through every one and simply find the biggest value. Once we have the biggest value, we need to loop the children again. For each child, ignore the text entries, and then set each child or each control's label width value to the max size. And that's doing what we did here when we manually typed them in. In essence, we're then updating that property. So now it will be the control.label and then the the dependency property, or rather control.label width there, the dependency property equals max size. And that needs to be a grid length. So we actually need to do a new grid length converter. In fact, we can new this up outside, so we're not creating it for every loop. And then the converter dot, in fact, this can all go outside. I don't know why I keep doing it in here. Or grid length equals converter dot, and then we don't need the variable now. We'll get there in a minute. New grid length converter dot convert from string, and then we'll simply take, I don't think there's a convert from, or is there a convert from double? Screw it, just do convert from string and just do max size dot to string. So cast the double back to a string, convert that to a grid length, and then cast that to a grid length as well. And then finally just set that grid length there. So that should first iterate all the children, find the maximum size width-wise of all of the children in the panel. And then once it's found that, it sets the label width value of each of the controls, which we know from here works. So when we compile, this should already show in line, which it does, which is cool. So that's it. So if we run that, that should be automatically in line. And there we go, they're all in line now. And then if we, I don't know whether design time will be smart enough for this, but if we were to, say, remove those two, it should shrink. Oh, and there you go, it's actually, it's working. I think it's working. No, it's not. Well, I think what you have to do is cut and then you have to build, just because of how the design time is not going to fire the events. So there you go, it's now aligned those two to the right size. You put those in, it'll align them up here. So it works in design time, it's just that you have to compile if you change the value to see it, which is nothing. So there's the values there. To test if this works with the size changed, let's just rename this class first. Rename the file again, I keep saying class. There we go. So let's go to the text entry view model. And where we edit the text, let's change that and let's edit the label. And then this should fire the size changed event, which should recalculate the labels and everything should stay in line. So we edited this one, say, with a longer name. You can see everything's moved, stayed in line. We edit it to small values. Does the max value reset? It looks like the max value doesn't work there. So we need to tweak. It worked one way, worked going larger, but didn't work going smaller. So let's do a breakpoint on size changed and run. And we'll hit this a few times on startup. So let's ignore that a minute. Now, if we were to go smaller, let's ignore that one a minute because that's larger than password. So now password, as we go smaller, this should definitely reduce now to a smaller size. So let's see. Now that hasn't actually fired a changed event. So I see what's going on there. We have, it's not going to change size because we've made it smaller and it's already set to a larger size. So as well as monitoring for size changed, we need to monitor for the label text changing as well, because that will effectively be if the text has gone smaller than, you know, the available size. So I'm hoping there's a text changed. Preview text input. Why is it an input? Content. Okay, if not, label is a text block. And I don't know whether we monitor the view model for changing. I'm just trying to think of, we should have, let's have a look at the control. Text block. See, we could monitor the binding, you know, actually monitor for the view model binding, but we don't really want to do that because that binding can change. We do want to monitor if the text has changed. Sure, text block should have an event for the text changing. Got torches, hit testers, mouse captures, visible, key up, key down. Maybe layout updated would I think layout updated would actually fire. So let's try that one. So now if we go smaller, we don't care about the first one. So this one is now, and now that's gonna update because I come out of edit mode maybe. Or is layout updated every time it's rendering? Yeah, so we're gonna hit this. Or let's just do a console.writeLine just to see what's going on without a breakpoint, because I think every time we we're focusing and unfocusing, it's re-rendering, which is, that's fine. There's no issue with that. But we just want to see in the output. Let's clear that. Make it larger. And then you can see there, it's rendered. In fact, that's rendered a bit too much for... I mean, this will work now, I bet you any money. So if we do that, it's fired, but it hasn't actually worked. We'll need to also remove the label. It gets tricky to go smaller, actually, because now we need to remove the label width to set it to auto before we update. So we'd have to loop each one. We'd have to do control.label width. And then this, I'm guessing, will not update because we're going to have to allow the UI to update first, which is going to cause like a glitch going back and forward. So in fact, no, saying that, this should be working because it's the render size that we care about. So even though the control... Oh, I know how we can fix this. I think by default, if this was... where's the width? If this width was, say, 200, and the background of this was red, wrong one. Background of this was red. There you go. So the issue is the controller's stretching. So all we need to do is horizontal alignment left, so it doesn't stretch. And now the render size would be correct. So now if we fired an event when this changed, it would work. We don't want this. Where are we? Don't want this layout updated. That's a bit too aggressive. I mean, that'll work. Let's just leave that in a minute to show that it works, because now it will fire, overactively, but it will update and it will shrink. So you can see there that already updated. That's gone smaller. That's gone larger. So that's working. And some people might be happy with that, but when we've looked at how many times this thing fires, it's a little too over the top. So I'm hoping there is a better way. I mean, I know it is technically the layout when it's drawn, but it's not really... We don't care about that. We want like the resized. But the size change isn't firing when we alter... In fact, no, I think the size change will now change because of the horizontal layout as well. So I think this will actually work now just with that horizontal alignment, because you've changed the text and now it's horizontally aligned. I think this will fire when we make them smaller. So change that to A, fires as we expect. Change this to A. Yeah, so it's now firing correctly. So there we have it. There's the, the auto aligner, if you will, to keep things that are... These are technically separate controls, but you want to kind of align them as if it was just a group grid. We've got the double click so we can edit the controls. And the next thing we want to do is get the password box in. So I'll do that in a separate video because this is a nice self-contained video. And I know people do like smaller videos where possible. So because we've got to a kind of conclusion here, we've done a solid task. It's all done and working. The next task is a clearly defined new thing to replace this with an editable password field, not just a plain text. We'll stop this video here. And then the next one, we're going to do this password field. So just before I finish it, let's just revert back that change in the text entry view model to original text. And then that takes us back to the app ready for the next video. So let's just double check before we go. Yep, you can double click, you can escape. Yep, and you can press enter. So that's that.